All right, so you should be on the unit circle page, and this is where we're going to spend a little more time. So I'm going to go over some stuff with you today about the unit circle. When I get Monday and Tuesday's group, I'm going to do a little bit more with the unit circle, and then y'all, of course, will be in here Thursday and Friday, which there was a page in the packet that I left out, so I will have that for y'all Thursday and Friday. Now, keep in mind, I did send out an email today reminding you the logarithm exponential packet and the test is due Sunday, I believe, or did I extend it to Monday? Anyway, that's due coming up, so follow the due dates in Math Excel, and then this test will be open until that e-learning day, December 21st. Is that the right date? Okay. So, yes, ma'am. You do not turn in the physical packet, but that is what your test material will cover. So remember the exponential log packet that we just finished up? All the video notes are in there. Look in November 30th and December 7th. All the videos are in there. You fill in what you don't have, and that way you have that for when you take your test. You're welcome. Y'all did hear me say that, so you would have your packet completely filled out for your test. Everybody get the underlying message there? Okay. All right. So this is a unit circle. What we spent our time doing yesterday was we were talking about degrees and radians. So in the inner part of the circle, you have all the degree values. And most of these are related back to the 30, 60, 90 degree triangle, 45, 45, 90 degree triangle. Okay. So as you rotate around, these are all those special angles. You see how this is 30 degrees away? This one is also 30 degrees away. Isn't 150 to 180 30 degrees distance? Then we have 45 here, but you also have a 45 degree angle. Notice I'm drawing all of this from the x-axis. How far are you away from the x-axis? Same thing here. That's 30 degrees away, 30 degrees away. 45 degrees away, 45 degrees away. And then, of course, you are 60 degrees away from the x-axis. Okay, so all of these little dotted lines either relate back to a 30, 60, 90 triangle or a 45, 45, 90 triangle. Now, with respect to all of these angles, the outside numbers, of course, are the radian equivalents. So if we did those little conversions that we were doing yesterday that y'all turned in for me, if you took 60 degrees and created the radian, it would be pi over 3. So they've given you all the special radian values, okay? Now, every single one of these dots has an ordered pair associated with it, okay? When you are at 0 degrees, you are at the point 1, 0. Now, I know it's 1 because a unit circle has a radius that is 1 unit. If you are working on a unit circle, the radius is always a 1. So I'm going to kind of zoom in so we can kind of see these numbers a little bit bigger. So when you are at this point, you have traveled over 1 unit, but you didn't go up or down. So that's a legitimate 1, 0 point, correct? Now, to get to this point, I have to travel so far over and so far up. So I'm traveling over to here, and then I'm traveling straight up, 90 degrees. There is an ordered pair associated with that. The ordered pair associated with this point that represents 30 degrees and pi over 6 radians is square root 3 over 2 and 1/2. So if you're working any angle and your angle terminates right here, these are the X and Y ordered pairs that you will use. And I'll explain what the X and Y's are in just a moment. So for the 45-degree angle, you're going to have the ordered pair square root 2 over 2, square root 2 over 2. Now, there is a 45-degree triangle right here. That's a 45, 45, 90 triangle. Okay? Now, you don't always have to draw in the triangles, but you need to understand that they are actually there in every single one of these angles. So when we go to fill in our 60 degrees, because that would keep going, that's going to be 1/2 square root 3 over 2. Now, as we rotate around this circle, you're going to see these same ratios repeat over and over and over again. All right? When I'm at 90 degrees, if I'm at the origin, I do not move left or right, but I go straight up 1 unit, correct? So at 90 degrees or pi over 2, the ordered pair associated with that dot is 0, 1. Now, when I rotate this way, it's almost as if these 3 points reflect. The only deal is when you get into quadrant 2, you start picking up negative numbers, right? Which value is negative, X or Y? Okay, so if I take this point and I just simply reflect it all the way across, and the reason I can do that is because this angle is 30 degrees from X, and this angle is also 30 degrees from X. Do y'all agree? Okay, that would be negative square root 3 over 2 and positive 1/2. The Y value is always positive in quadrant 2. So what do you think happens here? Because both of these angles are 45 degrees. So what do you think this ordered pair would be? Negative radical 2 over 2 and positive radical 2 over 2. Third time's a charm. This one reflects over here. What do you think the ordered pair would be this time? Negative 1/2 radical 3 over 2. Perfect. That is because you can relate these angles to being the same distance away from the x-axis. Don't ever draw the conclusion to the y-axis. Okay? 30 degrees here, 30 degrees here, 45, 45, 60, 60. All right? Now, that reflective property actually rotates into the bottom half. Okay? The only difference in third quadrant, everything's negative. Do y'all agree? All right? So if I am 30 degrees away, this point is also 30 degrees away. Do y'all agree? So now we're going to reflect this way. Oh, sorry, I totally skipped 180. What do you think the coordinates of 180 would be? Negative 1 and 0. That's correct. You start at the origin, you go over to negative 1, but you don't move up or down. I apologize. I just totally jumped over that one. So if both of these points are 30 degrees away from the x-axis, you're reflecting that point. The only difference is both numbers this time will be negative. What do you think we're going to get for the 225-degree angle? What ordered pair goes with those? Both of them. Yep. And then what do you think 4 pi over 3 or the 240-degree angle? right, so I want you to jot down what you think the last 4 points should be now that we know that kind of reflective property they've got going on. So I hope you kind of see the pattern going around the circle. It's the same numbers over and over again. 1/2, square root 3 over 2, square root 2 over 2, zeros and ones. All the way around the circle, okay? That's what I got. Fourth quadrant, X is always positive, Y is always negative. All right, any questions about that? All right, so now you have your unit circle, and they can ask you to find values in degree. They can ask you to find values using the radian, and it doesn't matter. If they ask you for 330 or if they ask you for 11 pi over 6, you're still going to relate it back to these two numbers. Okay, so at the bottom, we're actually going to go backwards. I'm going to give you the trig values with respect. This only applies to unit circle. These values only apply to the unit circle. Now, if they ever ask you to find sine of an angle, the outcome is the y coordinate associated with that angle. Okay? If they ever ask you to find cosine of an angle that's on the unit circle, that would always be the x coordinate. Then we kind of start getting into tricky stuff. The tangent, they can ask you to find tangent of any of these angles, positive or negative, but it would be the fraction y over x. But your denominator cannot be 0. If your denominator is 0, that means tangent is undefined. And that is an acceptable answer. You are going to have undefined values from time to time. Now, the secant, this is the reciprocal for sine. So cosecant, this is spelled cosecant in case you have never seen it before. That's how you say S or CSC, cosecant. I know it's really kind of small. I'll make that a little bit bigger. I can do that, I think. Oh, I thought I could. All right, that's going to be 1 over y. I'm going to take the sine values since they are reciprocals, and I'm going to flip y. So that would be 1 over y. Now, cosine's reciprocal is secant. That's S-E-C-A-N-T, secant. And that's going to be 1 divided by the x number. Okay, now keep in mind, no denominators can be 0. So in this one, y cannot be 0. In this one, x cannot be 0. Which means at some point, cosecant or secant could be undefined. All right, and then the last one is cotangent's reciprocal, which means I'm going to take the tangent fraction and flip it. So that would be x divided by y, as long as y does not equal to 0. So those are your 6 trig functions. Now, which 2 have no restrictions on them out of the 6? Sine and cosine. There's no denominator. Okay? So the only ones, you've got 2 with no restrictions and 4 that have restrictions. At some point, these 4 could be undefined. Okay? And then some places they're defined. You'll get an actual answer for it. All right? Now, positive trig values. What this means is, do you agree this unit circle is broken off into 4 quadrants, just like normal? You got first quadrant, second quadrant, third quadrant, fourth quadrant, right? Now, based on the quadrant that you are in, okay, let's say we were trying to find something to do with this 45-degree angle. So our angle terminates in quadrant 1. In quadrant 1, all 6 functions will always be positive. Are there any negative values in quadrant 1? There are no negative values in quadrant 1, which means there is no negative x, no negative y. So everything would stay positive in quadrant 1. Well, when you get into quadrant 2 has a negative x, but it has a positive y value. Okay, so what happens is once you move out of the first quadrant, when you go into the second quadrant, there are 2 positive trig functions and 4 negative trig functions. Okay, now when we move from quadrant 1, where everything is positive, and we start getting into negatives, out of these 6 trig functions, there's only 2 of them that do not require x. What are those 2? Out of these 6 trig functions, only 2 do not require x. Sine and cosecant. That means anytime you are looking at angles that terminate in quadrant 2, sine and cosine will always be positive because the y value is positive. If you take a positive number and you flip it upside down, it stays positive. The only difference is your numerator and denominator switch places. Now, when you get into quadrant 3, this one's a little bit tricky because both numbers are negative. So, if you look at tangent and cotangent, if you take a negative y and divide it by a negative x, does it not turn into a positive number? For cotangent, if you were to take a negative x number and divide it by a negative y number, would it not turn into a positive? So in quadrant 3, tangent and cotangent always have positive answers. The other 6 functions will be, or the other 4 functions, I apologize, that are not tangent and cotangent will be negative. All right, so in our last one, we have quadrant 4, positive x with a negative y. Which 2 functions do not require y? Cosine and secant. They will always be positive. The other 4, sine, cosecant, tangent, and cotangent, all require y, and y is negative in that quadrant. Does that make sense? Yes, no, maybe? Okay. So we just got a lot of this, so you can go ahead on this next page if I can find it. It's down here somewhere. Oh my goodness gracious. Maybe it's the other way. I don't know where it's at. Why will you not get me? There we go. I wrote down the page numbers so I wouldn't scroll, and then I scrolled. All right, so this is kind of a redundant point. The sine of theta is y if you are on a unit circle, so we're just going to write it down again, so we'll have it on this page with us. Cosine is x. Tangent was y over x as long as x doesn't equal to 0. Cosecant is 1 over y as long as y doesn't equal to 0. Secant is 1 over x as long as x does not equal to 0. And then cotangent is tangent's reciprocal, so that would be x over y as long as y does not equal to 0. Now, the cool thing about every single point, if you know for a fact, beyond a shadow of a doubt, you are on a unit circle, every single ordered pair is cosine of the angle and then sine. So instead of writing it as xy, it's cosine, which is x, and sine, which is y. So every time you're thinking about those ordered pairs that we just filled in on the previous circle, then you can think about cosine and sine. Now, the unit circle is frequently used to map 30s, 45, and 60-degree angles. And we talked about that, how in every quadrant there is an angle that is 30 degrees from the x-axis, 45 degrees, and 60 degrees. And any of their multiples, of course, as well as what they call the quadrantal angles. The quadrantal angles, that would be 0 degrees, 90 degrees, which is the positive y-axis, 180 degrees, which is your negative x-axis, 270 degrees, and then, of course, 0 and 360 are at the same place. But notice each one of these angles stops. This is why they're called quadrantal angles, because they stop at 90, they stop at 180, they stop at 270. They stop on an axis. All the other angles are somewhere in between those axes. Does that make sense? All right. So, in order to find trig values, now notice that some of these are positive, some of them are negative. We're going to talk about all of them. Some of them are in degrees and some of them are in radians. Does that make sense? Okay. So what we're going to do is we're going to find the sine value of 135 degrees. Now, remember, sine of any angle is the y value, okay? So you're probably going to have to flip back to your circle. And I forgot what page my circle is on. All right, so can't get to my page, but I can use this one. Here we go. All right, can y'all see this little bitty circle I got over here? Kind of matches your big one. All right, so this says it wants the sine value of 135 degrees. So I'm going to come over here to the line that says 135. I'm going to go out there. I'm going to look at that ordered pair, and I'm going to write down the y value. So sine at 135 degrees. What is the y value associated with that point right there on that circle? Square root 2 over 2, positive, correct? Okay. Now, secant, if you go back and look, secant of any angle on a unit circle is equivalent to 1 over x. Do y'all agree? Okay. So since they want secant at 180 degrees, this time I'm going to come here to the point that is associated with 180 degrees. That is -1, 0. Do y'all agree? Okay, so I'm going to write down the point, -1, 0. Since I have 1 over x, that would be 1 over -1 because that's your x value. So my outcome would be -1. Okay, so the positive values, you go to that angle, find the associated point, and pull out the value that it wants. Now, cotangent. Cotangent of any angle is what fraction? If you are on a unit circle with respect to y and x, what is it? X over y. Okay, so this time I need to find -300. -300 is not the same place +300 is. So I'm going to start at 0 and I'm going to rotate until I hit -300. This is -90, -180, -270, and then I go an additional. So this is actually equivalent to -300. Okay, so since I am terminating here, I'm going to follow that line to that point. I'm going to grab 1/2 radical 3 over 2, because is that not the point associated with that spot? Okay, so my x and y values are 1/2 radical 3 over 2. And I'm going to have to set up an x over y ratio. So x is 1/2. We're going to divide that by radical 3 over 2. Now, I'm going to show you the math, then I'm going to show you the shortcut, okay? So if I have 1/2 divided by radical 3 over 2, that turns into 1/2 times 2 over radical 3. The 2's will cancel, and I end up with 1 over radical 3. All right, I wasn't prepared for them to be here so early. We will pick up right there when we get back from lunch. All right, so we were in the process of solving number 13. So give me a moment. My tablet cut off. So we had gotten to 1 divided by square root of 3. Unfortunately, we can't leave radicals in denominators. And it's a quick, easy fix. So I'm going to take 1 over the square root of 3. I'm going to multiply both the top and the bottom by the square root, whatever the square root in the denominator is. When you multiply across, you get square root of 3. When you multiply here, you actually get square root of 9, which is just a 3. Okay, so even though this is the value we got, we have to clean it up because you cannot leave radicals in your denominators. All right, so that gave us 2 positives, 1 negative value. So down here, I need on number 14, I need cosecant. Cosecant, if you go back and look, that's 1 over y. Do y'all agree with that ratio? All right, so I'm going to rotate around my circle till I hit positive 120. So I am right here. What are the coordinates that go with positive 120 or 2 pi over 3? I know the first one's negative and the second one's positive because we are in quadrant. One half and then positive radical 3 over 2. Okay, so now we have to take 1 and divide it by y. So 1 divided by radical 3 over 2. if you take 1, and I'm doing old school, divide by radical 3 over 2, that becomes 1 times 2 over square root of 3, which is just 2 square roots of, or 2 over square root of 3. You cannot leave that radical in the denominator, so just like the previous problem, we're going to multiply the top and the bottom just by the radical. The top will give me 2 square roots of 3. The bottom will give me 3, because that actually multiplies to square root of 9, which is just 3. So my final outcome is 2 square roots of 3 over 3. By the time you get finished doing these particular lessons, rationalizing a denominator, which is getting the radical out of the denominator, will just kind of become second nature for you. A lot of times you won't even have to think about it. You'll just automatically start doing it. All right. So the next one is tangent. If you recall, tangent of any angle is y over x. I need the ordered pair associated with that 270-degree angle. Zero and -1. Y'all agree? So that would put -1 over 0. Well, what is any value divided by 0? Undefined. So tangent of 270 is undefined. And I told you that anything but sine and sine, or sine and cosine, could be undefined. And this is a situation where I end up with an undefined value. All right. The next one is cosine of -150. If you remember, cosine of any angle on the unit circle is the x coordinate. Now I've just got to find -150 and pull those ordered pairs off of it. So remember, when you go, -150 is not in the same place that +150 is. So I'm going to start here. That's -90. And I'm going to go all the way to here. This would be equivalent to -150 degrees. The ordered pair associated with that one, you should have negative square root 3 over 2 and -1/2. The answer is the x value. So the answer to this question is just square root of 3 over 2. Since the square root's in the top, we don't have to worry about doing any of the rationalization. Any questions about that? Just remember, positive angles go one way, negative angles go the opposite way. All right, so now we're going to look at a few that have radian values as opposed to the degree value. Now, if you don't like radians and you don't want to search the unit circle for these values, you can always do the conversion. So when I go back up to my unit circle right here, I do see 3 pi over 4. 3 pi over 4 is in quadrant 2. The ordered pair associated with that is negative square root 2 over 2 and positive square root 2 over 2. Do y'all agree with that? So I know my x and y value. So when I come back down here, cosine of any angle is the x coordinate. So if I'm using the ordered pair negative root 2 over 2 and positive root 2 over 2, my outcome is the x value. So my final answer is just that fraction. So find your angle, grab your ordered pair, fit it into the ratio. All right. 2 pi over 3 is also in quadrant 2. The ordered pair associated with that should be negative 1/2 and radical 3 over 2. Is that what you have when you look at 2 pi over 3 in quadrant 2? All right. So I know tangent is always the y value divided by x. And if I'm using negative 1/2 and radical 3 over 2, I'm going to put radical 3 over 2, which is y, divide that by negative 1/2. I know my outcome is going to be negative. Now, I'm going to show you a shortcut to where you don't have to do all the math. Okay? Do you agree that the two smaller fractions in the bigger fraction have the same exact denominator? This fraction has a 2, this fraction has a 2. Well, I can cancel those. And then I can reduce what's left to radical 3 over negative 1, which would just give me negative square roots of 3. And that would be my final answer. Now, I'm going to show you the math behind the shortcut. If you take square root 3 over 2 and divide it by negative 1/2, wouldn't that become square root 3 over 2 times negative 2 over 1? And the 2's will cancel. All I'm doing is cutting out all the steps. If the denominators of the numerator and the denominator are exactly the same, you can cancel them. That's a shortcut. Now, I'm going to let you go to the circle, locate pi over 2, and tell me the ordered pair that is associated with pi over 2. Zero, 1. Okay, I found my angle, I grabbed my point. Now I have to go back and think, okay, cotangent of any angle is always x over y. Y'all agree? So the x value, here's x, here's y. So that would be 0 over 1, which is 0. As long as 0 is on the top, do y'all remember the division by 0 rule? It is okay to have 0 on the top. It is not okay to have 0 in the bottom. Okay and no. That's why I always remember it. 2 little words. Okay? So I have students that every time they see a 0 in a fraction, they automatically say it's undefined. I have some students that every time they see a 0 in a fraction, it's automatically a 0. Okay? So just remember, those are 2 quick and easy little ways. Now, here, oh, there's my circle. Here we are rotating backwards, okay? Oops, wrong way. We are rotating backwards. So in order to find the location or the ordered pair, you have to go 45 degrees in a negative direction. If you look at your circle, positive pi over 4 is here. So and that equals to 45 degrees. So that means negative pi over 4 is equal to negative 45 degrees. So what's the ordered pair in quadrant 4 that goes with that negative 45 degree angle? Now, secant of any angle is 1 over x. Do y'all agree? All right. So I'm going to take x and I'm simply going to flip it. Now that's a shortcut. When you have 1 over x, and I can just simply take the x value and flip it. And I'll show you the math behind that shortcut. If you take 1 and divide it by square root 2 over 2, don't you take 1 and multiply it by that flipped upside down? So what's 1 times that flipped upside down? It's just the number flipped upside down. So as long as you have the 1 on the top, all you got to do is find the y or the x value and just flip it upside down. Now, we're not done because we have a square root of 2 in the bottom. Do you remember how to tackle that square root of 2? Multiply top and bottom by square root of 2 over square root of 2. Across the top, that gives me 2 square roots of 2. On the bottom, that gives me a 2. Square root of 4 is 2. These 2's will cancel, so when we clean that up, we get square root of 2 flat out. Everybody okay with that one? All right. 5 pi over 4 is on my circle. 5 pi over 4 is here. All right. So I'm going to use this ordered pair, negative square root of 2 over 2, negative square root of 2 over 2. So here's my ordered pair. Tangent of any angle is always y over x. So that would be taking the y, which is negative square root of 2 over 2, and dividing it by the x value, which is also negative square root of 2 over 2. What happens when you take a number and you divide it by itself? You get a positive 1. Negative divided by negative is positive. Sometimes, depending on the quadrant, you do end up with a negative 1 because one of these will be positive and the other one will be negative. All right. So, negative 5 pi over 6. One thing I want to remind you, you did this yesterday for me. If you don't want to go around the circle and figure out where positive 5 pi over 6 and then figure out where negative, you can always take your negative 5 pi over 6. You can multiply it by 180 over pi, just like we did yesterday. And that would be negative 150 degrees. A lot of times it's easier for you, instead of searching for the radian value, sometimes it's easier for you to go and get the degree value. Okay? So all I did was the conversions that we did yesterday. So this is the degree or the radian version. This would be what it would equal to in degrees. Now, I still need my ratio. Cosecant is 1 over y. So I still need to find the ordered pair associated with negative 150. Negative 150 and positive 150 do not terminate in the same place. So if I rotate negative 90, then I have to keep going to here. That's where negative 5 pi over 6 or negative 150 degrees would be. That's my ordered pair, right? So that was negative square root 3 over 2, negative 1/2. Since I want 1 over y, I'm simply going to take the y value and flip it. As long as it's 1 over x or 1 over y, that's all you have to do. When you take a negative 1/2 and flip it, that gives you a negative 2 over 1, which is just flat out negative 2. Any questions about those? Let's see what my next page is. Any questions about those? All right. So what I want you to do, the next page starts with number 5. Is that right? Okay. So we do evens or odds the other day, yesterday. Okay. So I want us to continue with the even theme.